we're going to let f of x equal the absolute value of 3 times the quantity x minus 2 plus 3 with its natural domain. In the first part of our question here, we want to find the 0 of f. Keep in mind when you're finding the zeros, those are the same thing as your x-intercepts, which means that the y value for each of those points is going to be equal to 0. So we're going to go ahead and set our function equal to 0. And the only time this function is going to be equal to 0 is if the stuff inside those absolute value symbols is equal to 0. So we're going to go ahead and solve this for x. And you have a couple different ways you can do this. Obviously you can distribute the 3 through the set of parentheses if you want, or you can work with it like it is, which is what I'm going to do. I'm going to go ahead and subtract 3 from both sides. This will give us 3 times x minus 2 equals negative 3. And then we can take this and we can actually go ahead and divide both sides by 3. So this will give us x minus 2 equals a negative 1. And if we add 2 to both sides, we're going to get an x value of positive 1. So the 0 for our function is at 1. So since this is an absolute value function, right, this one is shaped like a V. So that means it's going to be decreasing until we get to that 0. So from negative infinity to 1, it will be decreasing. And then after that point, it's going to start increasing. So it'll increase on the interval from 1 to infinity. Keep in mind when you're giving interval notation here, these are x values that you're using. You want to list your lower bound first, and then your upper bound. And this information should match up with what you see if we go ahead and graph the function. So I'm going to go ahead and include a snapshot of the graph of this function. Right, you can see that the x-intercept is at positive 1. Right, and our graph is decreasing from negative infinity all the way until that x value of 1, and then it'll start increasing at 1 all the way to positive infinity.